I don't think there's any point in telling you not to try this at home. You're either going to do this or not. But if you don't know the difference between this power supply and this power supply, with that information alone, you probably shouldn't be doing this. Today we're going to be taking a look at this. Now, this unfortunately named device is a ChugPlug. What it's meant to do is allow you to plug your MacBook's power supply directly into it and then plug into your MacBook to start charging. However, I cheated a little bit there and plugged it in because this thing sucks. If I unplug it here, you'll see it immediately dies. Now, that could be because this is the 85 watt MacBook power supply, but I don't remember having ever had a lot of luck with this thing to begin with. Currently, you can buy this thing for 15 bucks with free shipping on Amazon. Unfortunately, I paid around 40 bucks a little over 2 years ago. Now, for $40, I consider this thing a massive disappointment and a complete waste of time. But for $15, I have a really good bad idea to try. I'm going to take this thing, combine it with a dead MacBook power supply and a normal outlet connector, and try and make a 110 AC battery bank. Now, this thing isn't going to make a great battery bank. They claim it has only 4,000 milliamp hours of capacity, and it's only rated for 65 watts, which is rather conveniently the same as the mid-range MacBook power supply. So I would suspect the true rating's a little bit lower, to be honest. Now, 4,000 milliamp hours is a kind of strange rating. That could be two 18650s in here, or it could be one and they're stretching the truth a bit. Now, before we get any farther into this thing, we should see if we can even get power out of it. As you saw, it doesn't work with my MacBook, so for all I know, this thing's broken right now. Alright, so we have the trusty 34401A hooked up. If we take a power cable connected to an outlet and measure it, we will see 120 VAC. Excellent. And now if we connect to the ChugPlug, what will we see? So, alright, off, go to 0, push the button, nothing, hold the button, and we see something. Perhaps I should try connecting a load. I'm going to go ahead and plug back in here, see what we got. So 3 millivolts AC. Alright, let me plug this in, see what happens. So we're at under a volt. Okay. That's weird, because this does work when it's plugged in, so maybe it's, again, a load thing. And here's where we get to the dead MacBook power supply. Now, I really only want this for the connector, because it just slides in. Boom, done. So, ooh, you know what? That would be a good test. This is only a 45 watt one. Let's try and hold the power button to turn it on, I think, and then slide this on. Ah! Aha! We didn't immediately drain it, so, okay. This is an 85 watt power supply, so this may be overdrawing from this. Okay, I think we're on to something here. So that might be an overcurrent circuit protection. Powering it up resets that. Excellent. I think we're on to something. So let's connect this. So what we need to do now is I'm going to take this apart and just use it for the connector here and solder the outlet adapter on. Alright, now I'm not going to be gentle with this thing, so first thing I'm going to do is cut off the power cable here. Alright, and that's one dead MagSafe. Next, I'm going to see about prying the case open. Now, like most Apple stuff, they don't really make this easy, so I'm going to have to just get a little violent here to try and make this happen. I'm not quite sure where you do this or if there's a recommended way. Stupid heat-sealed plastic, my God. Of course, camera cut out. But I'm in. That was a lot of work. So, alright, again, all I need is that. And really, you know, actually, I kind of don't really need to trash a power supply for this. Even though it's a dead power supply. Because this is just a regular old figure 8 style power connector. But it doesn't hurt to just use what I should be using. Now it looks like soldering these in place will be just as simple as connecting everything like that. We can see some kind of N right there on the Apple connector, and this side is the neutral side. So that should be all we have to do. Let's go ahead and try that. I think ground may have some kind of anti-solder coating on it here. Let's see if I can get away with just sanding that off. It's looking a bit more metal-y. And now we have some kind of horrifying adapter. So, let's see if we can make that work. Now that we have our adapter, we're ready to try this out. So we're going to use this 15-watt JVC CD player to see if we can power just any old thing off of this battery. So let me carefully connect this, because, you know, it is hopefully 110 AC. And then turn power off on that right now. Plug it in. And I did double check. You are supposed to hold the button. Pushing it just shows you the battery status. Holding it till that comes on, supposed to turn it on. And we should get the CD player working. No. Are we getting 110 out of this thing? No, we are not. And plugged into an outlet, we can see the CD player does turn on, won't open. It's got problems, but that's another video. Alright, let's try another test. We're going to pass power through the Chug plug, connect to this, and then plug the CD player in. Nothing. Well, that's interesting because the MacBook did receive power then. So this is not working for some reason. Alright, I went ahead and tracked down my 60-watt MagSafe power adapter. So let's see if this works at all on here. We're going to plug in and see if we can get this to do anything. Alright, should be on. Nothing. Oh, wait. There we go. Alright, so that's functioning. That's confusing. Alright, this is interesting. I'm going to unplug the MacBook power supply, plug in power. Okay, now it's reset and it's all happy. I'm going to plug in the MacBook power supply, hold the button to turn it on. Okay, it's on. Boom. Charging. Well, charge now. There we go. I'm going to disconnect this and reconnect it, and bam, shuts off. And then it won't turn back on. So that current inrush into this is browning out the power into this, and it needs more to be able to reset. Okay, so you can hear a relay click when you turn this on. Let me hold it up to a microphone and turn it on. I hope that was audible, and I suspect if I slide this on now, yep, brown out. Okay, so I think I need to turn it on with the CD player connected, because then it may not brown out. Although I doubt it's browning out with the CD player since it's a much lower load. But let's try it anyway. And nothing for the CD player. Okay. I'm going to try flipping the neutral and ground wires and seeing if that makes a difference, because this may... Oh! I'm going to try something that's not the CD player. So, Guess who thought it would be a cool idea to plug a 34401A into this thing? And now it won't turn on. Huh. Let's stick to DC power supplies with this thing until I get it working right. I'm going to leave the 34401A aside for a little while and hope it has some kind of self-resetting fuse inside. I took the fuse out, took a look at it, and it looked okay. I'll bring my Fluke 287 in after I'm done here and check it for real. But for now, I'm going to go ahead and switch these in case that is my problem. I don't see how it should make a difference unless this is some really lame, well, it's going to be a lame pseudo-sine wave, but unless it's like super bad, don't see how it could cause that kind of result. Now, I tried the 34401A because I figured it's all DC components inside and that it would be internally regulated, and that's why it would be safe. I was thinking maybe the 1987 CD player needed a true sine wave and relied on that somehow. So it seemed like that wasn't the best idea to be using that. So I broke something that's worth a lot more money and much more precious to me. Yay. Alright, try that out. I guess if I'm going to be measuring DC power supplies, I still need a DMM. So I pulled out my 287 and I took the fuse out, and good news, the fuse is blown. Now the bad news is it's really, really tiny. I don't know where I'm going to get that. Ooh, fuse, 250 volts. Where do I... What's the current rating? 250 milliamps. Yeah, that's it. So I need a 250 milliamp fuse. That is tiny. The rating on this fuse is much lower than any of the other fuses I have, but it's also physically smaller than anything I've got on hand. So I'm going to have to order one of these. But at least this thing shouldn't be dead. The fuse did its job. So, oh man. That is a good feeling. Now I got to check that. Well, I did check the CD player powered up from an outlet. So, what gives 34401A? Why you gotta scare me like that? I have a strong temptation to be bad here. But, I like this thing too much, so I'll just wait. Okay, since that is resolved, let's go ahead and try this 5-volt, 500 milliamp power supply that I don't really care if I lose, and see if I can make this work. Go ahead and turn it on. Should be positive center, negative outer, and should be on. And oh, wait, did I see something? 6 volts. Ooh, that might be working. Okay, so is it really just flipped? I'll bet one of these is DC ground, and that's what the problem is. So, okay, now it's time to try connecting something slightly more interesting. Actually, one more thing before we go plugging anything else in here. Let me power this back up. Good. Double check it's working. Yep. I want to go to VAC and now see if I'm getting 110, 120. Still nothing. Why is it? Let me flip my leads. Yeah, that's really confusing. Alright, well, that's kind of working. Let's try something a little more complicated. Let's try charging a different laptop than this is meant to. So it's just a ASUS netbook here, but let's see if we can get this working. So, didn't brown it out, and plugging it in. Boom! We're charging this netbook off of that alone. Nothing else connected. Awesome. Alright. Let's see what else we can do. JVC CD player. Oh, turned off. Did it brown out? May have browned out. Let me reset it here. Alright. Yep, green lights are on, red lights on. CD player, yeah, it doesn't like that. Let me try this. Does that turn the CD player on like that? It does not. Interesting. Alright. So we may want to switch to devices that have switch mode power supplies for this. I think I'm starting to get closer with the switch mode power supply thing. Let me try this Brother P Touch with its 24 volt power supply, I think. Yeah, I think I'm onto something here. So this, yeah, actually I could hook up an oscilloscope. What do I don't know if any of my scopes can handle 120. Actually, I think they should be able to, but you know what, I'm not going to bother right now. This might be outputting a really horrible DC square wave, and only the switch mode power supplies can work with that. For grins and giggles, the power supply for my camera is now currently running off of this. Running the camera off of this thing isn't too bad of an idea, since the original batteries are about a quarter of the capacity if the rating on here is correct. Okay, so let's do some real measurements here. Now I'm going to take the 5 volt power supply from before, and I'm going to reconnect it to put some load on this thing. Alright, see where we're at on battery. We're doing good. Go and connect the negative side and the positive side. Alright, so we can see we're at 6 volts here. Now we have the scope here at 2 volts per division and at 2 milliseconds per division. I'm going to go ahead and probe here, and we can see that we're getting 1, 2, 3, 4 times 2, so it'd be about 8 volts. Now this probe is a 10x probe, so we're looking at about 80. So that should be about 80 volts. So for the frequency here, we can see we're about 1, 2, 3, 4, 5, 6, 7, 8 divisions away. So we're at 16, and that's milliseconds. So if we do 1 divided by, need that, clear, 1 divided by 0.016, we'll see 62.5 hertz there. So it's probably 60 hertz. And we can start to see the shape of the line here. I actually don't think that's too bad. We can zoom out a bit, see what they look like a bit more. Sorry about the flickering. I mean, analog scope, not a lot I can do. My, I guess I could have used my bit scope with a 10x probe, but whatever. So we can see here, it's actually not too bad of a sine wave, really. I know that you have to pay quite a bit to get a UPS that has a nice clean sine wave. I'd say that one looks pretty good. So let's see what this looks like when we put it under a different load. So we currently have no load on this right now. We're just double checking the 6 volt output. So let's swap to this power supply, which is 12 volts. So unplug that. Now we can see how that changed. Plug this one in. See, no load. Okay. Let's measure the output. And negative 12. Oh, that's, yay, negative center. Awesome. But we can see how the load does affect that. Now let's go ahead and plug it in. No change. Turn it on. Ooh, that's a lot fuzzier. So under load, it's not as clean, and that's a pretty dirty sine wave, really. Yeah, that's not that clean. So what could be happening is the older devices, like the CD player, and the more fragile devices, like the 34401, aren't enjoying this messy sine wave that this thing outputs. But the devices that use a switch mode power supply don't care as much, because this is isolated in a more direct way than just a straight up transformer would be. Now that we can confirm that this is doing the best that it can, I would say we're probably done with this part. So let's take a look at putting it back in the original case and making this nice and, well, safer. Now, what I'd really like to do is slide this back in place where it goes, and then have this be pointed up here where the original connector or cable came out. And that fits pretty well right there. There's no shorts or anything, so that'll do. I need to cut out a large bit of plastic here, but I think this is going to be pretty good. So let me go ahead and start excavating some plastic. Is that just taped on there? I'm not super thrilled about that. I think I'll pick that out first. All right. Here's the basic idea implemented. That didn't turn out too bad. So I'm going to go ahead and add some more wire to get this to be flush, and then hot glue everything in place. While I seriously doubt this thing's capacity to generate enough power to do any real harm, doesn't hurt to just be safe. Okay, well, it doesn't move too freely. Let's really get it locked in. This seems to be doing pretty good here. So that fits in place. I like that. This, yes. That feels good and solid. All right. So we're going to put the other end on, which is interesting because I can't, you know, glue once it's on there. So I have to just fill that in and then, you know, never be able to service this thing. So hopefully those are good. You know what I should do? I should test this before I go and make this permanent. Oh, that's kind of nice on there. I like that. So let me grab the 5-volt power supply that reads as 6 volts. We've been using this whole time. And double check it. Zero and 6. Okay, so we're good. All right, yeah, let's try this. There, that was a little while. That should be done. So I'm gonna pick that one off because that one's useless and ugly. All right, so this that spread, but whatever. That didn't really. That's it. That's done. So I could, and probably will go through and trim off some of the sharper bits, but I now have an outlet I can just plug into the ChugPlug. Well, I think that about wraps this up. It's hard to quantify what you should and should not use this for with the limitations it has. Now, it looked like it was only outputting around 80 volts, which could have been the problem with the 34401, that it tried to overdraw to power and that blew the fuse. So it's hard to quantify what this thing is good for. The CD player does not work with it, and that's likely because it was only outputting 80 volts. But while it did not work with the CD player, it will allow me to charge this Game Boy Advance. This has no charge. It even worked with my hot glue gun to make for a portable hot glue gun. But there are clearly some limitations here. So first of all, I would not recommend doing this unless you really, really know what you're doing. And if you do, be very cautious about what devices you use with it. Switch mode power supplies are going to be a lot more forgiving, especially that lower the voltage quite significantly. And pure resistive loads may work just fine, as long as I don't need to go beyond the 65 watts that this thing can supposedly output. But other devices clearly would not work. There's no way on earth I would use this thing with my Nixie calculator, so that's an idea of where you should draw the line. I also know I can't use this to make a portable 34401. So there's another hint. And I'm sure there's a lot of things that are limited like that with it, but it will work with some stuff. I think I'll probably end up using this most with my camera, functioning as a massive external battery. Well, I hope that was entertaining. There may have been some stuff that was educational, but I don't want you to have learned how to do this, because I think this is a bad idea. So, until next time, I'll see you later.